three equations you're going to look at. One of them relates to hot air balloons. So there are about three behind the house, right behind me. I'm not sure the zoom on this camera is good enough to see them. But gases is really how chemistry got its start back in the 1700s, 1800s, and mostly in France. And just as we sent a monkey to space first, and the Russians actually sent a dog to space first, the French, these guys that kind of looked at how pressure relates to volume and temperature, they were making hot air balloons. Instead of using humans, they put sheep, so attached sheep to balloons, heated up the air inside them. And so if you can just like close your eyes, imagine the French idyllic countryside, sipping your wine, eating your cheese, and meh, 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 these sheep floating around. So here's the podcast.
Alright, in this podcast we're going to look at gas laws. And there are several that I would like you to be aware of. Alright? And they all basically have the same or pretty similar format. There are actually 5 of them. 4 or 5 of them. Alright? And our first one is kind of the oddball out. But Avogadro, we've already learned about Avogadro's number. It has to deal with number of moles. Alright? And this first one is simply V over N equals some constant. Or really we can say V1 over N1 equals V2 over N2. Alright? And essentially, at constant pressure and temperature, the number of moles of a gas is equivalent or directly proportional to the volume of that gas. Alright? So if we double the moles, we double the volume. If we half the volume, we half the moles. But it's set up just like this, and we might say where pressure and temperature are constant. Alright? Are constant. Alright, and this is known as Avogadro's law. The names you don't have to be aware of, but I'm going to give you the names, but on a test or quiz you don't have to identify a certain law as a certain person. Okay? Our next one is going to be, we'll do this first three kind of like this, is going to be P over T equals P over T. Alright? And similarly, we're just going to say P1 over T1 equals P2 over T2. And this is going to happen where, so I'm going to do a little kind of same as above, where V and N are constant. Okay? So if we have the same number of moles, and it's in a container that's not expandable, so let's say in a paint can, in a milk jug, if we increase the temperature, the pressure is going to increase. Okay? And this law, if we're keeping volume, is known as Guy-Lussac's law. Guy-Lussac. Okay? He was a French guy, Guy Lussac, and there's Guy-Lussac's law. Alright? The next one is going to be V over T. Suppose V over T. And again, we're starting with the designation V1 T1 over V2 T2. And that just means at one point in time, a second point in time. Okay? If we take the same gas, and this gas is going to be where pressure and moles are constant. But if we increase the temperature, alright, what's going to happen, those molecules are going to move faster, and they're going to try to push against the walls of their container. So if we keep the pressure the same, that container is going to have to expand. So it takes a longer time for those molecules to go from one end to the other end. Because if pressure is the same, they're hitting the walls of the container equally. Okay? But if they're moving faster, the walls have to be further apart. So what does that mean? The volume is getting bigger. Okay? And this is known as Charles' law. And just another guy that did quite a bit with gases back in the, I think, late 1800s, early 1900s. Okay? Our last one, at least with two variables, is this one, and it's known as Boyle's law. And it is P times V equals P times V. Alright? And again, we're going to say P1 V1 equals P2 V2, where now temperature and moles are constant. Okay, and this is known as Boyle's law. B-O-Y-L-A-S, law. Alright, and another guy that was working on gases about the same time as Charles, really. Alright, so if we look at these three, kind of these top three have something similar about them. And it relates back to the graphing thing. So if we're dividing and getting a constant, okay? So really if v over n equals some constant, and v2 over n2 equals some constant, or really if we say a equals b and b equals c, then a equals c. So really these things all equal a constant, and they'd be equal to v3 over n3. But we're dividing to get a constant. So when we divide to get a constant, we have a direct relationship. As one thing goes up, the other thing goes up, right? Graphically, what is that going to look like? We're going to have a straight line on our graph, okay? Boyle's law, though, notice we're not dividing, we're multiplying. So if we multiply to get a constant, that is an indirect or inverse relationship. So in this case, Boyle's is kind of the one out, then it is going to look like the open face parabola, okay? So those are our gas laws. A couple of other things, if we use temperature. So we're using temperature in both Gay-Lussac's and Charles. Temperature must be in Kelvin. Alright, so we cannot use Celsius. And how do we get Kelvin? And we always add 273. Okay? Our last law is just known as the combined gas law. And it combines the last three of these. So we have P times V over T is going to equal P times V over T again. And again, at our first instance, we're just going to call these P1 V1 over T1 equals P2 V2 over T2. In this, the only thing that's constant is our moles. Okay? So if we have just a trapped gas in something, we can change the temperature, change the volume, see how that affects the pressure. We can change the pressure, the temperature, see how that changes the volume. We can affect the pressure, the volume, see how that affects the temperature. Okay? And this is something known as the combined gas law. Alright, and there are the gas laws. Pressure can be in really any unit. It can be in millimeters of mercury, psi, atmospheres, or kilopascals. Volume can be in any volume. Usually it's going to be in milliliters, cubic centimeters, maybe liters. And then temperature has to be in kelvins.